This is our linear programming question. So first of all, we need to start figuring out context of what we're talking about. So here we've got two types of car, standard and luxury. X is the number of standard cars and Y is the number of luxury cars. So along our x-axis along the bottom, that's how many standard cars we've got in our graph. And going up the y-axis, that's the number of luxury cars that we've got. Now obviously you can have combinations of the two different types of car, and they're the only variables we're considering in this problem. Now, it says figure 6 shows three constraints other than the fact that x and y are bigger than 0, and that they are x is greater than or equal to 20 and y is greater than or equal to 8. So if we look at the graph, they are those two straight lines, the horizontal line and the vertical line. Alright, let's have a look at part A. Write as an inequality the third constraint shown in figure 6. So we've talked about the horizontal line, we've talked about the vertical line, they were in the question. The last one is that diagonal line. So we have to, first of all, figure out the equation of that line. Let's use y equals mx plus c, as per usual. Well, our c is going to be 0, it's going through the origin, so the only thing we've got to do to find the equation of this line is to figure out that gradient. The gradient is rise over run, and if I draw a triangle under this anywhere I like, let's just draw it here, down this bottom bit here, I can see that my rise is 20 and my run is 20. So actually very, very straightforward. The equation of this line is y equals x. However, that's not an inequality, is it? What have we actually got here? Well, we've got this side of the line shaded. So that's what we need to be thinking about now. This bit's been rejected up here that I've shaded, and the clear bit down here, this is the bit that's been accepted. So I want to formulate this inequality so that it's saying yes to this part and no to this part. Let's pick one value that's actually accepted here. Let's pick this one here. Okay, at this point here, x is 65 and y is about 17. What's happening there? Is x bigger or is y bigger? Well, quite clearly, x is bigger, and that's a point we accept, that's a point we want. So what we really want here is for x to be bigger than y. Now the final thing we need to consider is whether it's equal to or it's just greater than. Well, let's have a look. It's a solid line, it's not dotted, so that means I have x is greater than or equal to y. Let's have a look at part B now. Now part B can look quite complicated. It can be quite hard to figure out, but what we know is that we've actually been given the answer, we've just got to find our way to work to it. So if we really don't know what we're doing, we can constantly go back and try again until we figure it out. Obviously you don't want to spend too much time on it, but that does help us. So the question says, the company decides it wants at least a sixth of the cars to be luxury cars. Express this information as an inequality. So, what it's saying there is out of our total of the cars, a sixth of them have to be luxury cars. Now our total is x plus y, because that is how many cars we've got in total. We've only got two types of cars, standard and luxury, so the total number of cars is going to be x plus y. Now luxury cars, we said, was y. So we know we want y to be at least a sixth of that total. So I've got y being at least, so that's greater than or equal to, a sixth of the total number of the cars that we've got. Now all we need to do is a bit of algebra to untangle that. So let's first multiply both sides by 6 to get rid of that sixth. So I've got 6y is greater than or equal to x plus y. Then I can subtract y from both sides and I'm left with 5y being greater than or equal to x, which thankfully for us is exactly what it said in the question that we wanted to simplify down to. The next thing I want to have a look at is part C. So in part C, what we've got to do is express as an inequality the additional information we've been given. So it says each time the cars are hired, they need to be prepared. It takes 5 hours to prepare a standard car and 6 hours to prepare a luxury car. There are 300 hours available each week. So here we've got a constraint which is all to do with time. We've got a maximum of 300 hours. So we know that whatever we do has to be less than or equal to that time, because we cannot go over those 300 hours. Now, how can we use that time? Well, it depends what we do with it. For every time we've got a standard car, that's going to take up 5 hours. So that's going to be 5x. Every time that we prepare a luxury car, that's going to take up 6 hours of our time. So that's 6 times whatever our number of luxury cars is. So that's 6y. And if we want to find the total amount of time, then we've got 5x plus 6y. So that's saying, let's say that we had 10 standard cars and 5 luxury cars, then we do 5 times 10 plus 6 times 5, see if that is less than 300. Only if it's less than 300 is that amount acceptable. So that's that expressed as an inequality. Now, we've got to go on to the next part, part D, which is adding lines to the diagram to illustrate both 5x plus 6y is less than or equal to 300 and 5y is greater than or equal to x, which was in part B. So, let's think carefully about how we do this. I always like to think about it just as a normal straight line, y equals mx plus c format, and draw it on that way. So I'm going to change. First of all, I'll do 5y is greater than or equal to x, because that came first, it was part B. Let's change that inequality sign to an equal sign, just to help us out. We've got 5y is greater than or equal to x. That means we're going to have y equals x over 5. So really, what we've got there is a line with gradient of a fifth, and it's going straight through the origin. So that means every time I go across 5 squares, I go up 1 squares. In fact, every time I go across from 0 over here on the origin to 50, that's 50 across. That means I'm going to want to go 10 up. So my gradient, I can just plot a little point exactly on there, 50, 10, and I know it's going through the origin as well. So that means I can then draw a straight line going through those points. So the line's going to look something like that. The next tricky part is figuring out which side exactly I want to keep and which side I want to reject. To do this, I always like to test a point. Let me test a point like 10, 10. Now that's going to be quite easy to test because they're quite nice round numbers. That's why I've chosen that. What I'm thinking about right here is this point here, which I can see is going to be above that line. And when I plug that into this equation here, I get 50 is greater than or equal to 10, because I did 5 times 10, so I got 50 is greater than or equal to 10. Well, that is true, isn't it? That's clearly true. 50 is greater than or equal to 10. So actually, everything on this side of the line, everything above that line I want. It's everything below the line down here that I want to reject. So what I'm going to do is, that's the area I'm going to shade. I'm going to shade everything below that line there, like that. Okay, so that is one of my inequalities dealt with. Now I need to do the next one. The second inequality that I've got to draw on is 5x plus 6y is less than or equal to 300. This is going to be a little bit more tricky, but we can cope. First of all, I'm going to pretend that's an equal sign, and I'm going to start rearranging. So I'm going to get 6y equals 300 minus 5x. And then I'm going to divide through by 6. So I'm going to get y is equal to 50 minus 5/6 x. Right, so I've got my gradient of minus 5/6x and my y-intercept is 50. So I know my line is going to be starting up here and it's going to be going down with a gradient of negative 5/6. So that means 5 is my rise, 6 is my run. I'm going down 5 for every 6 I'm going across. So let's say that I'm going across 60. That means I'm going to be going down 50. So from 50 I'm going to go down all the way to 0. And that means at that point, that is 50 down. That means I have to be going 60 across. So actually, this line is going from this point here, 50 here, down to down here, 60 down there. Now, let's draw that line in. That's my line there. Now, once again, the final thing I need to do is figure out which area I want to shade in. Which area am I rejecting? Do I want to reject this area down here, which is below that line, or this area up here, which is above the line? Well, what I'm going to do is I'm going to, again, choose a point to test. I'm going to choose the origin this time. The origin is down here, which is below the line, so the origin is everything associated with this side. Well, when I stick the origin in, that's really easy. I've got 5 times 0 is 0, plus 6 times 0 is 0, so is 0 plus 0 less than or equal to 300? Well, yes it is, of course it is. So I know that this is the area that I like, this is the area that I'm going to accept, which means this side is the one I'm rejecting. So now I can go and I can shade in that side that I am rejecting, just like that. Right, I have now illustrated the constraints in part B and C, so I have done that part of the question. The very, very final thing I need to do, which is nice and easy, is simply label my feasible region R. So that's the last bit here that has not been shaded in, and I'm going to label that R, and then I've done that part of the question. The very last part of the question is always actually using what we've done with our profit function or our cost function, trying to find the cheapest or the most profitable vertex on our graph. So let's have a look at that profit function. We've got P equals 80x plus 80y. We're being asked to use the ruler method, so that's where we place our ruler on that graph and we move it until we find how far away can we get from the origin. We're trying to get as far away from the origin as we can because we're trying to maximise profit. So let's again try to figure out what gradient we're going to have to hold this line at. I can visually just see from that it's going to be a gradient of -1 because this and this are the same, so when I divide through by 80, but if you're not convinced, let me rearrange it for you now. We've got 80y equals minus 80x plus p. Divide through by 80 will give us y equals minus x plus p over 80. So that means that our objective line is going to have this mystery intercept. We don't know what the intercept is going to be, but we know the important thing, which is the angle we can hold our ruler at. That blue line that I've just added, I've made sure that it's got a gradient of exactly, or as close as I could get, to -1. So this is how I would position my ruler in the exam. I would have it going like this, right? And at some point, I would position it somewhere on my page, and I would just draw a line against that ruler going down so that I've shown that I've actually got my profit function, I've actually understood what I'm doing, and I've got a profit function that looks a little bit like that, just somewhere on my page so that they can mark that and they can give me a nice mark for that. But that's not actually what I'm using my ruler for. I need to be moving that ruler until I've moved it out to the furthest vertex that I can get it to hit. So, well, I'm going to start at the origin. Because I'm maximising, I want to go out as far as I can. Right, that's my first vertex that I'm hitting there, the one right in that bottom corner. That's clearly not as far out as I can get it. I can go further. I've just hit another vertex there, more towards the top. That's clearly not the furthest one out I can hit either. So I'm going to keep going. I'm going to keep going out until I'm hitting... Which one will I hit first? Oh, look, I just hit that one at the top before, so that's not my maximum either. I can go even further. The one I can hit absolutely last, the furthest out, so the maximum profit, is that one there, right down here. So that one is what I'm going to label as V, my vertex. Okay, so I've labelled it V. I'm ready to rumble. I've got those 3 marks. But then I've just got to do the part G of the question. Given that P is the expected profit in pounds per week Find the number of each type of car that the company should buy and the maximum expected profit. Now, remember this point is just like a set of coordinates, right? I can find the coordinates of it. So when I read down how many X I need, which is the number of standard cars, it reads off as 48. So I need 48 standard cars. And if I read across, it will tell me my Y value. Now, if I had done this more neatly, it should come out as 10. I have 10 luxury cars. Those are the figures that I need to plug in to my profit function. So I've got my profit function here, my 80x plus 80y. I'm going to put those numbers in. I'm going to do 80 times 10 plus 80 times 48. And that is going to give me my profit. So that comes out as, when I do all the maths, £4,640. And that is my expected profit for the week.